Hello, everybody. Thank you for joining today's webinar entitled Developing Packaging That Performs. Before we start, I wanted to go over a few householding items. So this is a Lansmont Corporation webinar, and Lansmont falls under the umbrella of the Physical Properties Testers Group, or PPT for short. The PPT Group is a family of brands, all of whom are experts in the design and production of physical properties testing solutions. These solutions cover a range of physical properties, including tensile and compressive testing, torque testing, textile analysis, and real-world dynamics such as shock and vibration. The other companies within the PPT family are McMesson, James Hill, and Telluris. If you're interested in learning more about any of our partner brands, you can visit the PPT page and see the content and on-demand webinars they have available. I am going to put a link in the chat box right now if you are interested in visiting that page in the meantime to take a look. That being said, I wanted to introduce some people on today's call. Eric Jonason is our presenter for today, and my name is Sharon Smorenberg. I'm one of the organizers. We then have various support staff throughout the United States, Europe, and Asia. Feel free to ask questions. You can use the question box throughout the webinar to type in any questions you may have. We will then address these questions at the end of the webinar. This webinar is going to be recorded, so you will get a copy of the recording to the email that you're registered with. If you want to review anything for additional clarity, or if you have a colleague who was interested in attending but wasn't able to make it, please feel free to pass the recording on to them. And with that, I will pass you over to Eric.
Sorry. Okay. Can you see me? Okay, I apologize. I can't see if my camera is showing on the screen.
Yes, your camera is showing, Eric.
Okay, thank you. Thank you, Sharon. I appreciate it. And I apologize that I can't see it for some reason. But I just quickly going to introduce myself before I do turn my camera off, just to save bandwidth, as I do have some videos embedded in the presentation. And I'll try to, not distract those that are attending, and also hope to preserve some of the bandwidth as I move forward. But my name is Eric Jonason. I am Vice President of Technology for Lansmont Corporation. I have been with the Lansmont Corporation I'm in my 34th year with the company. The only company I've worked for out of college. I have a packaging degree from Michigan State University from a long time ago. And I'm going to walk you through an introduction to this 6-step method that we use, and that was established for developing packaging that performs. This is a method that was developed a long time ago, right back at the beginnings of my company's foundations in the 1970s. So you might say, why are you telling us about something so old? But quite frankly, part of it is a little bit of a history lesson, but part of it is also because the method still is relevant and valid today, and quite frankly, I think beneficial for people as they move forward. And people are still using it, which we'll discuss here further. So I just wanted to introduce myself, and I'm going to get going now. I'm going to turn my camera off and look forward to any potential questions you might have at the end, or follow up via email. Thank you. So Lansmont Corporation, just these quick brief introduction about the company. We were founded in 1971. We are located in Monterey, California, where we have all of our engineering and design and production and support is based out of our headquarters in Monterey, California. And we provide basically shock and vibration, for the most part, dynamic test equipment that simulates real world dynamics. And we use or follow what we call the field to lab methodology, which basically says measure what all those bad things, those dynamics and the hazards within the supply chain, and use that data to drive what type of laboratory testing you perform with your packaged products. So we make technologies, design and manufacture technologies used for all bits and pieces of that methodology. Generally speaking, two main categories that I'm showing here, vibration and shock test systems, and that why we separate those out in this kind of, what we do description. It's because those products can be used for and are used for product specific testing to determine product robustness, fragility, or durability. So that's for bare product testing, bare products, components, but not so much package testing. We also have all the test systems that you see on the bottom of the screen, which are used for package testing. So once you understand the robustness and fragility characteristics of your product, obviously people then design protective packaging and need to validate whether that the protective properties work. Will it actually protect my products during simulation of a supply chain channel or distribution environment? So we make products that address all those categories: product testing, but then also package product testing. As I mentioned before, we were founded in 1971, and this is really kind of relevant to the presentation that I'm talking about here, because we're going to be talking about the development of this methodology. So the foundation of the company was really based on shock testing of bare products, which was associated with a methodology called the damage boundary theory. And the work that was originally took place on that was done in cooperation with Michigan State's University School of Packaging, located in Lansing, Michigan, and a company called Monterey Research Labs, which was located in Monterey, California. And eventually that combination of cooperation and collaboration between people in both of those locations resulted in the founding of Lansmont. So that's where the name comes from. A little bit of trivia on the front end for people that don't know that. And it just so happens I wanted to share that back in September of last fall, some of the people that were in the pictures on the previous slide that were associated with the founding of my company got back together relatively close to where I live to basically discuss and relive and document some of the history associated with the founding of this type of technology. They call it the Big Bang Theory. But basically, how shock and vibration testing kind of changed the world in our space, which is really as it applies for designing protective packaging to protect those products. So we got together back in the fall and discussed, kind of this origins, where it started with Michigan State with Dr. James Goff, who was the director of the School of Packaging at that time, that said, hey, I know some people in Monterey, California at this company called Monterey Research Labs that do shock testing. And we connected Dr. Goff with a gentleman who is based at the Naval Postgraduate School, which is located in Monterey, California, who was super smart about shock and what's things called shock response spectrum, which is highly technical for a lot of people, hard to understand. But the idea was, hey, given what you know, could you develop a simpler approach to this shock response spectrum or shock testing? And that led to the development of industry standards. And what I was shown just on the screen before was really industry standards that were developed and adopted within ASTM D10. ASTM D10 is their committee on packaging. And so that really triggered a lot of development on the Lansmont side, not just for shock testing, but really with the whole idea of our business development. And again, I apologize if you might be questioning why I'm talking about kind of this old information, but I did a lot of research myself over the last 2 years for a number of reasons. One, we celebrated our 50th anniversary from when we were founded in 1971, just a couple of years ago. But also because, we're trying to help put together this story of the foundation of the company. So I had access to things like digging through our archives to find the original business plan of Lansmont Corporation that was submitted to establish this company in 1971. Don't expect anybody to read anything here, but what it mentions here is that Michigan State contacted what was then called Monterey Research Labs to participate in a cooperative program for the development of a product package testing procedure. And that procedure was called the systematic method, not 5-step, not 6-step, but originally was called the systematic method. And what they did is kind of to prove out the method and the value of it, will it actually work and provide good results? They worked with a company based in Italy at the time, Olivetti company, which made typewriters at that time. I think they stopped making typewriters maybe in the 1990s, but it was an Italian company that that actually had worked with the original founders to say, would this methodology work? And this is in the 1971 timeframe, which to me is also very interesting. There's a case study, basically, right? There was a case study that was generated. If you look at the dates on this, this was submitted to this periodical in 1971. That kind of walked people through the challenge that Olivetti had and their goal to reduce packaging cost, supply chain costs, packaging costs through some new and improved methodology. And basically what this did is prove out that by implementing that methodology, they were able to save $614,000 a year. Whether that's a big number or not, maybe in 1971 still is that a big number or not. What it did though is it proved that this methodology worked. And if you look at kind of like the old packaging versus the new, it's obvious in that case that they were using less, right? As a result of going through the method, they used less. They reduced transportation costs. They reduced packaging costs. If you think about it, back in 1971, even then, that is a sustainable outcome, right? Using less packaging, saving costs, and still delivering products with quality. So it kind of proved out our methodology at that point, which was, again, a great thing. So what was that systematic method at that time in the 1970, 1971 timeframe? The original method, basically, I'm not asking again to read it, but I'll just highlight these. It says, determine the conditions which are encountered during shipping and handling. It means understand your shipping environment, your supply chain environment, all those hazards that are in those environments. And then number 2 is define the fragility of the product. Fragility, we also use other words like ruggedness, we use words like robustness, durability, but understand those characteristics of your product. And once you understand those, select the most economical packaging materials. What do I need? Based upon what I understand about the environment that I'm going to transport these products within, and how I understand the fragility of that product itself. What do I need from a protective packaging perspective to get it through the supply chain? Once you know what those materials are, you design and fabricate the package, and then lastly, you would test that package, doing some type of laboratory distribution simulation test. And what I wanted to point out here, which, again, in digging into the archives of myself, is back in 1972 timeframe, Lansmont actually developed our first ever environmental data recorder for characterizing basically how things were handled and dropped in the supply chain. So even then, we had a product that was developed to deal with that step 1, which is, understand or characterize the supply chain environment. Okay, so last couple quick slides here. Just wanted to say that Lansmont's first ever sale of a machine in 1971, 1972 was shock and cushion testing equipment sold to Dow Corporation. Dow was our first ever customer, packaging supplier at that time, and they basically bought technology from us specifically to implement that type of procedure, this systematic approach. And they were our first customer, which I think is interesting, okay? So enough of that history. Where are we today? What is this 6-step method today? It's basically the systematic method plus 1 step. So step 1 for us now, define the environment. Step 2, assess product fragility. Step 3, provide product improvement feedback. That's the addition to the 5 steps that were in the systematic approach, as simple as that may be. I'll explain, why that's actually a kind of great addition to the overall methodology. Step 4 is evaluate packaging material performance. Step 5 is still design the package system. And then step 6 is test the product package system. Okay, so this is a more fluffy way of looking at everything, and I'm going to go through each of these steps in more detail, but this is, kind of a look at the 6-step method in a linear fashion, as well as taking a look at some of the technologies that we use for each step, for kind of delivering and producing each one of those 6 steps. And then this is just to show you, as I've been digging into the archives, a gentleman named Dennis Young, who was originally one of our company founders in proving out the methodology. He was someone that I worked for early in my career. I started in 1989 with Lansmont Corporation, but at the time, Dennis was in charge of training for Lansmont Corporation, and found an old video of Dennis talking about the 6-step method. Unfortunately, in a picture I shared earlier, we met with some of these original founders back in the fall. Dennis was part of that meeting, and he subsequently passed away after some challenging health issues right after the first of the year. He was a great mentor to me, but thought I would just share a quick little video from him. Hopefully you can hear it. I realize there's very likely lag in the sound compared to what you see on video. We will be sharing all these, not only the presentation as recorded today, but also any videos that I use in the presentation itself later.
The goal of product and package development is simple. We're trying to get the product to the customer so that it can fulfill the customer's needs with the least possible cost, and to have the product arrive in good condition. In order for that to be accomplished, the product and the package have to work together, sort of as a team. And the product development and package development teams of people have to work together too. In order to reach this goal, packaging professionals have developed what's called the 6-step method of package development. Step 1 is to define the environment. The second step is product fragility assessment. Step 3 is product improvement feedback. The 4th step is to evaluate packaging material performance. In step 5, we design the package. Step 6 is to test the packaged product. By using the 6-step method of package development, we can begin to approach an optimization of the product and package system from a cost point of view.
Okay, so yes, old video, maybe hard to have the audio and the video work together, but some really, kind of relevant takeaways from me when I watch that is one, he talks about product and package working together basically to get things through the supply chain. So there's a relationship there that I like to talk about, which is shown in this basic fundamental formula, which says the product plus the package have to be equal to or greater than the environment. And what that really means is that the product durability, how robust is my product, plus the protective packaging characteristics have to be greater than or equal to any of those bad things that happen in the supply chain. And our world from the Lansmont side is definitely, the shock and vibration or compression. Think of dynamic hazards. There's obviously other hazards in the supply chain, such as temperature, humidity, atmospheric pressure, change in atmospheric pressure that challenge package integrity. But, we're focused on, in my company, on those dynamic hazards. Another way of looking at that quickly is to say, if we have this supply chain or distribution environment that has all these bad things that can take place, and we look at that in terms of hazard intensity, if a product is so durable, built so well that it can exceed or handle any of those hazards, you might have a situation where no packaging, actually protective packaging, is required. And quite frankly, there are a number of products that fit into that category. Really, if you think of today's world of mobile electronics, phones and other devices, even some tablets and things like that, they don't really need protective packaging from a shock and vibration perspective. They may not. So that's a great situation, right? You still might need packaging to protect it from cleanliness, theft, things like that. But from a shock and vibration, the more durable the product, the less packaging, protective packaging you need. The reality is, in the greater scheme of all the products moving out through the supply chain, most things do need packaging, right? So if the product doesn't have enough on its own built into the product, you need packaging to get it through that supply chain. That's a good situation or an okay situation. If you don't have enough packaging, it's underpackaged, you're going to have damage. That's a really bad, that's probably the worst case scenario, right? If you damage product, there's nothing worse than wasting the amount of resources and energy that went into building that product, or if that product is food, for growing that product and producing that product. But the other scenario is so if you overpackage, right? So that's an overpackaged situation, and that's okay, except that you're leaving money on the table, or you're spending more than you need to. The other downside to that is if you're overpackaged, you're wasting materials, and it's not a very sustainable solution. So it's not optimized, and that's not a great situation. This is a scenario, that we promote, obviously, through even the 6-step methodology that says really an ideal scenario is if you're gonna need packaging, let's put more effort into taking a look at the product itself and see if there are opportunities for us to improve the robustness associated with that product, the durability of that product. If we can improve that, if you have, let's just say any amount of resources to put towards either the product or packaging, if I put $1 of effort or resource into improving the product versus $1 into expendable packaging, that's a win, because that value then remains with that product and adds value to the consumer, the eventual, whoever that product is delivered to, versus putting it into packaging that might not be recycled or reused and go into a landfill. So that's really kind of an ideal situation for us. One more look at this graph. We say in that formula at the top, product plus package greater than or equal to the environment. When we talk about why do we care about the environment? Because really, when we characterize it in terms of its hazard intensity, we're really using that characterization to eventually drive the testing intensity that we use in the laboratory, right? So it's really important to understand the severity. What's the upper envelope there of that red dashed line, because we use that information and understanding to drive physical testing, laboratory testing and simulation, shock, vibration, compression. It determines those inputs. So jumping into to the individual steps, and what I want to just mention, we'll mention at the end of this as well. This is going to be a series of webinars, right? So I'm kind of just at this point providing an overview of this methodology. Each one of these steps is really basically has its own, webinar or training session that talks about how you go about defining the environment or assessing product fragility. So for right now, I'm just going to provide overviews of these individual steps to help explain, basically what we're talking about when we say define the environment. So step one, define the environment. So wherever products move, that environment is typically involves some amount of damage potential, right? From how it moves through the supply chain. And there's obviously a number of different modes of how things move, whether it's trucks, trains, airplanes, ships, or all the individual, manual or mechanical handling that's involved throughout any of those supply chains. So it's important to understand and quantify that potential. And so, what we do is we measure. I mean, we measure, we monitor using things like the data recorders that I'm showing on the screen to understand. Obviously, a lot of the understanding can even take place from an observation perspective. Seeing is believing, right? So if you're, a lot of people, even when I was young, was taught to go out and walk your system, basically. Go out and interact with your supply chain so you can see with your own eyes how things are handled and moved, because that, is a super informative and educational experience. But a lot of times, you can only see when things are being handled or changing modes of transport. So you don't know what's happening while it's in motion. And so that's why, data recorders of various types are often used to help characterize what's taking place throughout that entire journey. And then we use that information one way or the other to establish testing, which I'll talk about moving forward. So just wanted to, say once again that this kind of information is used as the basis for laboratory distribution simulation test standards. And what I'm showing here is on this screen is the original, I'll call it maybe the foundational environmental study that was done and published. So this is called the FPL 22 report. And this was something that was done and published in 1979 by the Forest Products Laboratory here in the United States. And this was really ended up being the foundation for the development of ASTM D4169, which is a widely recognized distribution simulation test procedure. A lot of the original inputs that said, how are we going to drop packages? How are we going to shake them? How are we going to crush them or compress them? A lot of those original standards originated from this study where they looked at trucks, rail cars, aircraft, ships. They looked at coupling speeds, at drop heights, at shock data, and they even includes the original statistics, as simple as they are, from how they summarized this information, including things like this, which is from somebody that looks at a lot of data myself. You're looking at power spectral densities, vibration power spectral densities, which are the information that's used to drive vibration testing in a laboratory setting. So you see some of this data. Of course, there's, again, for me, this is 50, well, however many years ago. There's better, we've come a ways since 1979. So there's new and improved, yes, new and improved ways of doing all kinds of these evaluations and metrics, or generating these metrics. But great to see all this information. So, there is this type of data that stands behind laboratory test standards. There was in 1979, in the early 80s, for ASTM D4169. There continues to be more today. This I'm sharing more as a representation of not only did that occur back in that time frame, but even today it continues. So this is from the ISTA's website, the International Safe Transit Association. One of the pages there, if you look at research, is called Distribution Environment Data Collection Program. It continues to go out and basically perform measurements that from ask for and actually fund research that is looking at different environments, supply chain environments in Europe, in India, in China, eventually in South America, to go out and do these types of studies so that people can say or address regional considerations and hazards. Because yes, if the 4169 once upon a time was based upon a study done in the US, people in the Philippines might say, that's great, but what about my world? What about my environment? Same people, same in China, same in India. So these kind of efforts continue today to go out and do these characterizations so they can establish eventually test standards that are reflective of those environments. Step 2, assess product fragility. So yeah, hazards are unavoidable within the transport environment. So it's really important to know something about the durability or robustness of your products. Are they, depending on what your products are they ceramic tableware, or are they mobile phones? Those are maybe a couple extremes of something that's very fragile versus something that's very durable, and it's different. And how can we characterize that, and develop quantitative metrics that speak to that? And there are different ways of doing it. There are standards for how you do that from a shock and vibration perspective, which is, again, it's an entire webinar just talking about and showing examples of how you go about that. But it's key, right? It's key to how can you really effectively design packaging if you don't really understand one way or the other something about your product from a robustness perspective. So that's a really important step. And then step 3, as simple as it is, I don't have any videos or pictures to show there, and as simple as it is, the point here is, once you understand, let's say, the initial fragility or robustness of your product, is there anything you can do to make it even better or more robust? And we have lots of examples throughout our time, with our customer base, of situations where, yes, if you find that you're testing a product and you're shaking, let's just say shaking on a vibration table, and as you run it through a test, even fasteners, nuts, bolts, screws might back out during the testing, or circuit boards, or some type of a beam involved in your product or component may break. Is there anything you can do to stiffen things up or soften things in the product design itself versus putting the money, again, into packaging, dealing with it from a packaging perspective? Because if you can make a better product, that's the ideal kind of sustainable, by definition, result, because that value then makes for improved product quality, and that quality is delivered to the customer, who then gets to keep that quality as part of their product. So it's important to really pause at this point for step 3 and say, can I make my product better? Is it good enough, or do I need to take a look at opportunities to make it more robust? And then step 4, evaluate package material performance. Basically, what do I need? Now that I understand what my product is, and now that I understand what the environment I have to ship things through, what do I need to be concerned with? Do I need to look at materials that help me from a shock and or vibration perspective? Does that packaging need to go above and beyond to help with structural rigidity from a compressive perspective? Now that I understand, again, what the kind of robustness or failure criteria is associated with that product. So you go pick, basically there are methodologies, which is, yes, another webinar eventually to address this from step 4 of how you go about that. What are the tools, what is the testing used to establish packaging material protective performance, and what are the results? What are the results, the analytics, the metrics, and how do I use those? Which is actually really, really interesting, I think, and powerful. And it's something that I can tell you in my work that I see fairly often, that people are not using some of these tools and resources to try to address challenges. And so that's almost the idea why I had of revisiting this 6-step method, is because I see people that can still benefit from some of these procedures, and pausing to go through this process to help eventually end up with a better, more optimized package design, if they were just aware of the resources that are available to them. Step 5, design the package. Pretty straightforward, right? Now that you pick your materials, you know what you have to deal with, you go out and you design the package system. That's something that that me and my company, we don't get so heavily involved in, but that is obviously the next step, which is to design, use the information that you've learned and established, what the protective packaging materials that you're going to use, put them together, and then as part of the step 6 is test it. Test the product package system. So that's not just testing the packaging, that's testing the product and the package as they're working together, and put it through some type of simulation of your anticipated hazards, right? So that's goes back to really reverting back to that step 1 that says, what's the environment that I'm shipping in? And it doesn't mean everybody needs to measure everything in the world. There's been a lot of measurement that's taken place. There's been a lot, and there is a lot that's even occurring today. And a lot of the measurement people can do on their own as a company, if they, for some reason, feel like they have a unique supply chain that's different from the general public. But that's what, industry standards, consensus body industry standards like ISTA, ASTM, even ISO has test procedures. Those test procedures themselves are based on some type of measurement and observation that took place in time, and they're continually updated, right? So it's not like they just are stagnant, that was developed in, let's say, 1979 or 1980 and hasn't changed since then. Yes, sometimes change is slow, but in any of these standards organizations, those methodologies are reviewed on a fairly regular basis to say, are we still good, or is it still good, or do we need to change something based upon some new understanding of that environment? And that's very real, and that happens quite often. I'm myself heavily involved in both ISTA and ASTM, and and part of various work groups that do take a look at, is it time to update? Do we have a need to update? So that's what we use, though. We use the understanding of the environment or some type of representation of the environment to kind of validate the protective performance of a packaging system. All right, last thing that I'm going to just show here, I'm going to show one last video. And again, these videos will be available, but I think this is kind of speaks to, so this is Bill Kipp that you're seeing on the screen. He is one of Lansmont's original 4 founders, talking about, what I think is a very relevant example of the bits and pieces of the method being used by, in this example, by DuPont over our history. But it's a good example, and it's just kind of a teaser of some of the things that I plan to share in future webinars. So I'm going to play this now, and these videos were put together by a colleague of mine named Dale Root, which I'm showing down at the bottom right-hand screen, who used to work for Lansmont and is heavily involved in kind of helping to document some of this history. So I'll play this video real quick. I'll be quiet.
Ken and Ed did a consulting program for DuPont. DuPont came up with this idea of a machine that would automatically analyze body fluids. It's a pretty big machine, maybe the size of a washing machine or something like that, maybe larger, shipped on a floating pallet. Apparently it would get to the other end and things would be misaligned so that the analyzer parts didn't work right, or they would literally find fasteners loose in the bottom of the crate and stuff like that. The floating pallet had been designed such that the resonant frequency of the floating pallet system coincided almost precisely with the critical frequencies inside the product. So you take a little bit of an input, you amplify it in the package, and it starts damaging or destroying the product. Well, the solution was to decouple the frequency of the pallet from the frequencies of the product, and that meant taking out cushioning material. Well, I mean, any fool knows that if you got damage in shipment, you throw more packaging material at it, right? So this was sort of like, I think for the DuPont guys, you mean we save money in the floating pallet and this solves our damage? You guys are geniuses.
The one and only package design I ever did.
So hopefully that at least the audio came through there. that's, an example that Bill Kipp talked about that's very relevant and representative of even case studies that I've worked on. 11 of my years at Lansmont Corporation were spent in our own laboratories where we provided contract testing services. And I worked on many projects that had those same kind of outcomes as Bill mentioned, where people did not go through the methodology to understand their product and just started developing protective packaging that actually made things worse, because they didn't use the right materials, the right amount of materials, the materials in the right places. And in the end, I literally have examples, like Bill said, of people that actually pulled material out of the design and addressed and solved the solution, which in today's world is almost the definition, right, of sustainable packaging. So I wanted to share that video because I thought it was just that short clip, but the message in there is really related to this method, the implementation of this method, thinking through this method, whether you're going to do all 6 steps or not. So that's all I've got today, about 40 minutes into it. So I hopefully some of you are still with me and still with us, and just wanted to let you know that the upcoming schedule for webinars is I'm going to dive into now detail in each one of those steps, giving some real, hopefully interesting and good examples, starting with step 1 with defining the environment, and then step 2 talking about product fragility testing, where you're doing the product shock and product vibration fragility analysis. So with that, thank you very much for sticking with and paying attention, and we'll be just open now for questions. So I'm going to pass it back to Sharon, and just to let you know again, this presentation will be made available as a recording to everyone that's attended, be posted on the PPT group website, and if anybody's interested in any of the video clips, I would be happy to share those as individual pieces as well. Thank you.
Thank you very much, Eric. So just an invitation to anybody that has a question to post it in the question box right now. But we already have some questions, and
Okay.
I will share those with you. Let me. I just need to go up.
I'll be happy to answer if I don't get to them here at this point. Be happy to address them in follow-up emails, communication, whatever it takes. Happy to respond. But go ahead. I'm sorry, Sharon.
Okay, let me start. So if we are changing shipment type from air freight to ocean freight, how do we validate the climatic fluctuations in ocean containers, like temperature, humidity, any specific suggestions, like subject the packaged product to 24 hours for 50 degrees and 80% RH and proceed with ISTA?
Yeah, there are. I mean, if the individual that's asking the question does use either ISTA or ASTM, within ISTA they have different preconditioning scenarios that you can use, like tropical, basically high humidity, high temperature, and they also, the other thing that's you get through membership within that organization is access to research that's taken place, to, let's say, papers and presentations that have been provided over, I've been involved in ISTA since pretty heavily since like 1996. I'm actually on their board of directors. And so I've seen these kind of presentations and papers presented, and there's been a number of studies on those kind of conditions. What do they really look like from a measurement perspective? So that's even interesting information. I can also tell you, just generally speaking, when it comes to climatic conditions, what's really interesting is that the worst scenario for anything that's moving in the supply chain is when it's sitting there, when it's not moving. As long as things are moving, as simple as it is, it's way better situation, because you're just by the dynamic movement itself, it's pulling heat and things like heat, and even it's moving air. It's not letting it sit stagnant and getting dwelling in horrible conditions. And the other interesting thing I'd say about ocean shipments is, even though you think, okay, it's going to be really maybe warm and humid when you're shipping things, maybe in the tropics, but remember that the ocean itself is a big heat sink, right? It's got a temperature associated with it, that body of water, as does the ship. And if that ship is moving, one big heat sink and then over or through another big heat sink, it's actually fairly moderate, as far as the changes, the extremes, especially the changes of the cycle. You see much more cyclical nature of temperature and humidity when things are moving over land than you do over sea, because the reasons I just shared, one, it's moving on the ocean, two, the ocean is temperate, and three, the ship itself is a big heat sink. So none of those things can respond necessarily very aggressively to changes in let's say the daily temperature and humidity cycles in the air. So I don't know if that's helpful. I would certainly steer you towards, if you're worried about heat and humidity effects on packaging, to consider some of the more tropical preconditioning environments before you put it through the testing itself, the physical testing, dynamic testing. Long answer, sorry. Hopefully it's semi-relevant.
Thanks, Eric.
Yes.
So I think the next question speaks again to the fact that this is an introduction to a series of webinars, which I think we might not have made that clear in the abstract. But the question is just, is there a more in-depth training available on the 6-step method?
Again, there will be more webinars that we will deliver, over time. So it will be there in its total when we complete our webinar series. We don't currently offer any pre-scheduled 6-step, say, seminars or webinars. We've done that in the past, and we do consider training on a case-by-case basis if it makes enough sense. I do that. I've done that plenty in my past, and that takes, that can be a couple-day class. That's why we don't do it online, because to really dig into it does take a commitment of time. There's a lot of information. It's not like crazy, graduate level discussion, but it is too much to try to deliver in an online setting, in my opinion. So yes, we would entertain it. I would be happy to entertain potential training opportunities. If someone wants to reach out to me, even with the email that's included here on the screen.
Thanks. Next question. My apologies if I missed the point. Just a clarification. Is Lansmont a machine manufacturer, or is it a company which might provide services in this field? For example, ECT, COBB, internal dimension verifications on secondary packages, compliance with ISTA protocols, etc. And taking advantage of the situation, are you going to share the slides for further reference?
Yes, we will share the recording of this entire presentation. It'll be posted right on the PPT group. We'll follow up with everyone that's attended with email with links to all of this, but all the different questions there. So Lansmont is only equipment manufacturer. We provide the technologies, the test equipment, the measurement equipment that's used to deliver the things that are in that methodology. The one thing I personally, some of us at Lansmont do get involved in that step 1 procedure, which is define the hazards in the environment. I get involved in a lot of measurement projects, whether it's through universities doing research, through the standards organizations, or for company-specific projects or challenges where they have a reason to go out and do some more of, focused measurement to look at a situation in their supply chain. So we do offer help with those, but we don't have our own testing facilities. We did once upon a time, but that was back, since 2007. We no longer do the contract testing services. We just offer the equipment and technologies that deliver that type of testing.
Thanks. Okay, next question. Does Lansmont have any data or published articles on low pressure testing in different types of cargo aircraft?
We don't. Our instrumentation, the Sabre instrumentation, can measure it. Not only the dynamic part of it, meaning how the aircraft are moving, but we can measure pressure. That's an easy thing to measure atmospheric pressure. So you can see when planes take off, what the pressure is at the altitude for how long, as well as combined with any dynamics. There's a study that was done, I'm going to say it was maybe the 2010 timeframe, which really kind of established the vacuum, the vibration testing under vacuum conditions that are included in either the ISTA, let's say the ISTA 3A test procedure, or within ASTM's 4169. It would be used in there for again, vibration testing under vacuum. But I think there's room for, not just to promote people going out and doing measurement. There is discussion about trying to understand that more clearly, what the kind of the maximums are for jet aircraft as well as feeder aircraft. And now in the whole another world, these technologies apply to people that ship all kinds of products, right? And that can even, when you start talking about medical products or biologic products, some of that stuff is even headed towards being delivered by drones. And so how high do they fly? And of course they would likely not have any pressurization capability associated with them. But there are questions about that. And I can tell you there are people that are talking about more and more what I would refer to and other people refer to as combined environment testing, which means don't just do atmospheric pressure testing in a chamber and take it out, and then do vibration testing for 1 to 10 hours, and then take it out and then do temperature and humidity testing. The combined environment testing says if that packaged product is going to be exposed to all of those simultaneously, test it that way. So your vibration system may be in a temperature controlled environment with an altitude chamber placed on top of the table. So all three of those conditions might be simulated simultaneously, because you might expect a different result of how your packaged product responds to all those combined environments versus any one of them just by themselves. So because people are talking more about that type of approach for certain high value, high risk products, I think there's an opportunity to understand, as the question was asked, to understand what those atmospheric pressures are. Not only what the maximums are, but the duration of the exposure to those maximums.
Thanks.
Mm-hmm.
For the Lansmont Sabre 3X90 or similar, does the company have any recommended method for tracking location in parallel?
We are going to, we have a product that's one of our Sabres, the Sabre 9X30, which is the largest and most highest performance instrument, has one of the configurations where GPS is built into that actual instrument.
Sorry, Eric, can I just interrupt? I didn't see that person actually clarified further on. It said for use in tracking over the road or rail shipments in North America.
So I don't know if that means tracking in real time versus none of the instruments that we currently offer are anything that you can track in real time. They all can track location, or capture location data and report on location data after the fact. But the way our instruments work is you set them, you program the instrument up front. You say, go record this based on these triggering conditions over some period of time. And then after it arrives at a destination, you download all that data, which can include location data. And that location data can be captured within some of our instruments, but we also offer a standalone GPS logger option that records, so you can have a GPS logger on the outside of a truck, an ocean container, or a rail car that's collecting location data, where the saver on the inside is doing its shock and vibration work. And then after the fact, you can merge that data together within our software. That's a current existing capability. Basically says, if you know, each of those situations you record has a time and date stamp associated with it. So if I know I was in Denver, Colorado on Thursday, and I know that this big shock event happened at the same time I was in Denver, we can splice that together to tell a story of not only what happened, but where it happened, if that makes sense.
Right. And then I see a final question here. And that again comes back to the webinars. It's just how much technical detail will there be in the September webinar?
I would say a fair amount more, not so much the history lesson. So I apologize if it seemed a little bit light on technical information, but that was by intent, because it's we need to be focused time for each step to dig into the technical details. So I will go into much more detail in the subsequent webinars, technically, which may be good or bad depending on who you are out there.
Thanks, Eric.
Yeah.
I don't see any more questions right now, but if you are out there and you have any follow-up questions you'd like to have answered, please send them to Eric at the email shown in the chat. And I just want to I've just shared that right now, so you'll be able to see his email. It's ericjonason_@lansmont.com. And yes,
I'm sorry, I'm using my new email address that's shown on the screen now. It's okay, but I'm using the PPT group. Either one of the email addresses will work, but we as a company have changed over to a group email address, which is what's shown on the screen right now. So
apologies about that.
No, that's okay. Yeah. Sorry.
So just a reminder that this session has been recorded, and this will be shared with you in the next day or two. So everybody who's registered for the webinar should get this. But sorry, there was just another question, but it was just a thank you. But thank you very much for joining us today, and we will shortly be sending out invites to the rest of the follow-up webinars that will obviously be, as Eric says, quite a bit more intensive in terms of looking at the 6-step method. But we look forward to seeing you on these webinars. But for now, that's all from us, and we will speak to you again, and we're going to end the webinar now. Thank you.
Thank you, everyone.